Welcome back, friends. We will now begin the next lecture on non-motorized transportation, where we will look at pedestrian data collection and flow characteristics. In this lecture, we will show to you the different methods in which you can collect pedestrian data, as well as give you a detailed understanding about the different flow models that can be used or that are used in modeling pedestrian data along different facilities, and also look at regression modeling and how you can use regression modeling in developing these flow models. So, when it comes to collecting pedestrian data, you can do it in various ways. The first most common way of doing it is the manual counts, but this is effective only when you have a facility that has very few pedestrians that walk. If you want to collect data on a residential street or a street along which there are not very many people that walk, then it is easier to have few data collectors who are will stand on the side of the road, and just collect, just count how many pedestrians are walking. So, this is count data. Okay. So, we are not collecting data on the type of people who are walking, are they male, female, what is their age group. We are not going to hand out any survey questionnaires to them. We are just having data collectors stand on the side of the road and count the number of people that are walking by him or her. So, that is a very basic method of counting for pedestrians, right, and you have to have all the count data, because you have to know the volume of people that walk along the street. So, once you know the count, then you can sum it up and say that per hour there are n number of people that walk, or per day there are n number of people that walk, and then you can figure out which is the most congested period along the sidewalk, which is the lighter periods of along the sidewalk, and maybe if that sidewalk is connected to a signalized intersection, then you can go ahead and determine how much time may be given for these pedestrians based on the volume of pedestrians that approach the crosswalk or the intersection. How much signal timing should be given for them to cross across the streets. So, this is the basic requirement of designing any facility, is to understand how the volume of people walking, and hence these counts are done. It is very labor intensive. So, you have to maybe hire a lot of people who will do this manual counts and stand on the road side of the roads for a longer period or for a long period of time. However, now there are a lot of automatic data collection or count collecting devices that are available. For example, the slab type device, which can be buried under the walkway, and it works on the principles of pressure. So, if pressure is applied on it, it will automatically count as a vehicle. Then there are something called pyro boxes that can be mounted on a light pole, and it can count the number of people that are crossing the box. It has some infrared signals that it can count the number of people walking, and you can have urban posts and fixed counters. So, this is an urban post that are fixed counters. These can be removed. These counters can be removed, whereas these are fixed counters. There can also be sensors that can be put on some kind of a structure above a sidewalk or above a gate. So, you will see a lot of automatic doors that are nowadays present in different facilities. They will have sensors on top, so that when somebody walks in and out of a facility through that gate, they get recorded. So, you can count the number of people that are coming in and out of a facility, or so and so forth. However, there are some constraints. If it is especially in outdoor situation that you are putting these automatic counters, then they have to be shielded from weather or theft, and locations have to be selected very carefully. Now that you are going to install something for automatic counts for a longer period of time, better install it at the right place in the right angle, so it can count people correctly rather than double counting a same person. Or for example, what often happens with automatic counting is that if there are two people that walk side by side and you have a device that is not overhead, but that is on the side of the road or the side of the footpath, then both of the pedestrians are counted as one. So, we call it as occlusion in many situations, that two people are counted as one, then the volume counts get halved almost. So, it causes a problem. So, the location and the placement of these automatic devices is very, very crucial. Again, they need skilled labor. Now, not only for installation, but for extraction of the data, you will have to have people who understand how to extract this data and count it then. So, and the devices itself are a little bit costly. However, the accuracy of the counts, if done properly, is very high, and you almost do not need to have these people stand on the side of the road for a long period of time to count them manually. There are cameras also. So, rather than having sensors, people also have cameras or take advantage of the cameras that are already existing in many of the intersections. For example, you would see here to count the number of people that are crossing the street. Usually these counting is done manually, but usually nowadays there are a lot of computer vision techniques that can be used to count the number of people that are crossing that are captured on a video. Okay. Now, in the last lecture, we introduced you to the basic three diagrams of flow parameters that are very fundamental to any traffic movement, and these are borrowed from motorized vehicular movement, but they can be applied in case of non-motorized and pedestrian transport as well. So, if you recall, the basic equation is Q is equal to U times K, where Q is the flow, U is the velocity of speed, and K is the density. So, now you can also say Q is equal to U by S, where S is nothing but the inverse of density, and that is called as spacing. So, when it comes to looking at these diagrams for pedestrians, we usually use spacing as the parameter rather than density. So, or we use it alternatively in different kinds of cases. So, if we look at each of these diagrams carefully, what we can see is that the speed and density have a inverse relationship, right. So, if there are density meaning number of people per square meter, say, right. So, if there is no people or no density, then you can walk at whatever speed you want to walk at, right. So, that is called free flow speed. You can walk at whatever speed you want to. However, as the density starts increasing, as more and more people start to walk along that given space or the sidewalk, then the speed of the individuals walking starts decreasing, and it comes to a point where we call it jam density, where nothing moves, right, you are stuck. So, you can when there is congestion and the vehicles are not moving, you experience that situation, and sometimes when you are in a very crowded area, maybe there is an event happening and nothing is moving. So, that is kind of jam density, right. So, speed and density have a inverse relationship. Now, when you look at flow and density, you start to see that it is a parabola. So, when there is no density, automatically means there is no flow, there are no people at that point in time that are walking on the street. As density starts picking up, flow also starts picking up, right. So, as more and more people start moving, there are more and more people moving per minute, right. We will see what the flow units are, what the density units are in a little while. What as per the characteristics of any parabola, you will see that you will attain maximum density at exactly the midpoint from jam density and 0 density, right. So, at that point you will attain maximum flow, and then again as your density starts increasing, keeps on increasing, your flow does not increase anymore, right. So, there is a point at which there will be maximum people moving on that section per minute, whereas if there are more and more people getting added, the speed right, people don't, there is too much friction, there is too much congestion. So, there are the number of flow, the number of people passing a point per minute decreases until again you hit jam density. So, there are, as per characteristics of parabola, any flow unit, a particular flow point will be occurring at two different times based on two different density numbers, right. That is how a parabola works. Similarly, if you look at the relationship between speed and flow, it is also parabolic in nature, where when the flow is 0, again when there are no people, you can essentially walk at whatever speed you want to walk at, right. It is a free flow speed. Now, as number of people start increasing, your speed starts decreasing, right. Your speed start decreasing, and your speed is maximum at Q max. At maximum flow, your speed is maximum. Again, at the same time, your speed no longer increases after this point, and it goes back to 0. We will see how this works in the following slides. So, I hope at least you understand the basic principles in the three different diagrams that are presented here. So, what is pedestrian speed? Is usually the average pedestrian walking speed in terms of meters per second or meters per minute. Flow that I was talking about is the number of pedestrians passing a point per unit of time, right. We usually use number of pedestrians in every 15 minutes or pedestrians per minute also can be used. Density is the average number of pedestrians per unit area. So, we usually use pedestrian per meter square, and space is just the inverse of density. So, it is the average area provided for each pedestrian, meter square per pedestrian. Okay. So, when we talk about flow, what we are saying is that if this is a point, the number of pedestrians that crosses this point per unit time. So, per minute or per every 15 minutes, how many people cross this point, that is what is called flow. So, there are different models that can that have been developed over the years that capture the relationship between speed and density. The very simplistic model that I have shown you before, which is a Greenshields macroscopic stream model, which gives a very linear relationship between u and k, whereas Greenberg's logarithmic model says that it is not linear, but the speed kind of is logarithmic in relationship with density, and Underwood's exponential model now says that no, it is not logarithmic, but it is exponential in nature when it comes to the relationship between speed and density. We have already kind of explained you about this figure, right, but the relationship between speed and density is given by this equation. So, speed at any point will be equal to the free flow speed minus the ratio of the free flow speed to jam density times the density at that point in time. Okay. So, this is the relationship between speed and density in terms of the two values of free flow speed and jam density. Now, what this equation usually is what we call a regression equation, right. These are equations which estimate the value of the speed of the pedestrian. There once you know the relationship, once you know what your free flow speed is, what your jam density is and what your given density is, you can estimate the speed for speed of the pedestrians walking. So, that technique is used, the technique used to estimate this is called regression technique. Now, you already know that the speed when there is no friction from other objects, k is equal to 0, you can reach free flow speed. Jam density at which no movement is possible is jam density, the intercept is u f and the slope is u f by k jam. Similarly, we have also already looked at what is the Green-Shields macroscopic stream model when it comes to the relationship between flow and density. So, if you replace, since q is equal to u times k, if you replace replacing u is equal to q by k in this earlier equation, right, we already know this equation. Now, if you replace u is equal to q by k in this equation, you get a equation of the parabola. So, this gives you the relationship between q and k, that is the relationship between q and k. Again, density at which no movement is possible, that is jam density. Max density occurs at midway. So, k is equal to k jam by 2. Okay. So, this anywhere it is k jam by 2. So, this k max is k jam by 2 and max flow occurs at k max, max flow occurs at k max, simple. Similarly, rewriting the equation of in terms of u and q, you can now get the relationship between u and q. So, basically if you understand this basic equation of u and density and knowing that q is equal to u into k, you can determine the parabolic equations of q and k as well as q and u. Again, we have already seen at mean free speed q is equal to 0 and max flow occurs at a speed that is half of the speed of mean free flow speed, right, or free flow speed. So, maximum speed occurs at half of free flow speed. This is half of the entire free flow speed. Now, for example, you are given this problem with these values of k and u. Okay. So, k is density pedestrian per meter square and speed u is speed meters per minute. Determine the parameters of the flow model. Now, you are told to estimate or determine the parameters of the flow model and find the flow and density corresponding to a speed of 30 meter per minute. So, you not only have to determine the equation, what the equation is, right, but you also have to, once you know the equation, you have to substitute u is equal to 30 meter per minute in order to estimate what is the flow and what is the density at that speed. Okay. So, the Green-Shields macroscopic model is the relationship between u and k is a straight line and it resembles a very basic linear regression form, right. Y is equal to a x plus b, where x is speed and y is density. So, this equation, and we all know how you can solve a simple linear regression equation of y is equal to a x plus b. It is done by a technique called curve fitting, where b is given by this equation and a is given by this equation. So, what are the elements of this equation? It says that all of the x values minus the mean of x value is multiplied by all of the y values minus the mean of y value, and the product of that is summed and divided by the all of the x values minus the mean of the x values times 2, which is again summed up. So, that gives you the b value. So, in this case what is x? In our case, which one is x and which one is y? We have already told you that speed is x and density is y, right. How did we tell you that? We already know that speed and density, right. We are looking at speed and density, or are we looking at speed and, yes, we are looking at speed and density. So, speed is x, density is y. So, we are going to find out first the parameter b, and then we are going to estimate parameter a, which is nothing but the mean of all the y values minus b times the mean of all the x values. So, let us see. So, we have the x values and the y values. So, first we do the we sum all these up, we sum all the x values, we sum all the y values and find out the mean of x and mean of y. And then we start, for each row we take the x value, subtract it from its mean, we take the y value, subtract it from its mean, we sum these two columns, or we have the product of those two columns, and then we also develop what is called the x minus this square should be outside, right, this square should be outside. So, it is this column raised to the power 2. Once we have developed these two columns, we sum them at the bottom and we find out that using the equation given in the previous slide, we found out that b is minus 0.2 and a is 40.8. So, then we get an equation which says the relationship between speed and density is speed is equal to 40.8 minus 0.2 times density. So, that is the relationship between speed and density. Now, we also have to figure out the relationship, the other two relationships, the relationship between density and flow and speed and flow. So, as we know, mean free speed, if we know this, we can tell that mean free speed occurs when k is equal to 0. So, mean free speed is equal to 40.8 kilometer per hour, and for q, for the equation of q versus k, the relationship now becomes q is equal to 40.8 k minus 0.2 k squared. Remember how we derived it from earlier, the relationship from how we moved from the relationship from u and k to a relationship from to q and k. This is a parabolic relationship, whereas this is a linear relationship. Now, we also know that at q is equal to 0, k is equal to k jam. So, if you put q is equal to, substitute q is equal to 0 here, we can find out what is the k jam equation by solving this quadratic equation, and found out that k jam is equal to 204 pedestrian per meter square. This is when the footpath is completely crowded. And also we know that at q when q is q max, k is equal to k jam by 2, right. We have already established that. So, if you use the same and put it in this equation, we will get the q max as 2081 pedestrians per minute. Now, we have determined what is q max, we have determined what is k jam, and we also know the relationship between q and k. So, now we can solve the second part of the question asked what is the what is q and k when the speed is 30 meters per minute. So, using our relationship that we have already developed, we can find out, we can just substitute u is equal to 30 to find out what the k is, and from this relationship we can substitute k as 54 to find out what the Q is. So, you see what these equations help you to do is that now for a different facility, right, you only have to determine the speed of people walking at that facility, and it will automatically, using these relationships, you can find out what the Q and the K are. You do not need to again do the calculations and figure out what the K and Q and K is. You just have to know what the speed is, and you can automatically determine the other two parameters. There are, like I said, this is a very simple relationship between speed and density, which is linear, is what Green-Shields found out. However, there are two other relationships that are also used, or the equations in that case are a bit different. In Greenberg's model, the relationship between speed and density is given in this fashion, whereas in Underwood's model, the relationship is given in this fashion, and as it is exponential. So, if you are asked to solve a problem given a certain method, so if we say that find out the relationship using Greenberg's logarithmic model, then you have to use this formula, whereas if we tell you to use Green-Shields model, then you have to use the formula that was shown earlier. Now, there are, based on these, if you understand these three basic parameters, flow parameters in pedestrian transport or in any forms of transport, you can then use these to build different models. Some models may be very specific to your location, your country, your state. Some may be homogeneous, some may the entire state may follow a similar model, the entire country may follow a similar model, but you have to understand the basic three parameters that were discussed. Now, based on this, there are different types of models that already have been developed. So, if you look at very broadly, these modeling techniques or softwares are classified under two groups. One is behavioral models and one are movement related models. So, the behavior models again can be classified two different ways. Conceptual models, which usually follow what is called or which a model that is developed based on the conceptual behavioral model is called the social force model, and you can, but the other type are computer simulation models that simulates the behavior of individuals. So, you have different kind of softwares, Legion, PedRoot and SimPed that does that. So, there are modeling techniques or modeling softwares that are available that model individual pedestrians behavior, but they are all based on those three flow parameters: flow, speed and density. Okay. Now, if you are looking at movement or the techniques and softwares that rely on movement, they do not consider any human factors or behaviors. Whereas these behavioral models, they do not focus on crowd dynamics, they are more dependent on individual behavior or individual concepts, right. These are more, they do not consider individual behavior or human factors, they are more focus on the movement of groups of people. Now, even in the movement type of models, there are two different types. One which considers a fluid or particle system. So, it assumes that fluid behavior as per Boltzmann gas equation holds true in case of pedestrian movement, whereas there are matrix based systems that are essentially used in the Highway Capacity Manual 2000, and different softwares are that are listed here are based on each of those principles. So, we will not get into the different softwares in this class, or however, we will tell you the, now that you know the basics of how these softwares work, you are free to go ahead and explore any of the softwares or techniques that you may wish. Again, these are some of the references from which the current module or the current lectures were developed, and for your further reading as well. So, in conclusion, what we looked in this lecture were the different data collection techniques, their advantages and disadvantages of each, from manual to automated to video data collection. Again, they all dependent on the time and money that you have for your facility that you are building, you can use any one of those techniques. And then we gave you the basic relationship between speed, flow and density, which are essential to understanding the flow parameters or flow characteristics of pedestrians walking along any facility. All of those we used an example of the Greenshields model, which is a linear model, and how the linear model can be estimated. We showed you an example of the regression technique that allows you to estimate the linear relationship between two parameters. Thank you very much.